Okay. Hello everyone. Thank you so much for coming today. Thank you so much for inviting us. Joe, thank you so much to the Numerai community for opening itself to more project and to other data science project. I think this is very cool and it shows a lot of maturity from this ecosystem. I think we all learn a lot from Numerai, and I'm going to be so transparent about it. I was an early fan a long time ago. I think I met Joe in 2022 at the Numerai in San Francisco. And back then we were kind of pretty close to kind of project. And we piloted a lot since then. So my name is Jo-fai, and I am the co-founder and the CEO of CrunchDAO. CrunchDAO is also CrunchDAO. CrunchDAO is a small group of data scientists that started in 2020. We were 14 data scientists based in Europe. And we started to basically crunch data for some hedge funds. One hedge fund called Crunch Capital, that is US based. And we slowly extended our work. We started to work for other hedge fund and institutions that I cannot name here. And we recently worked with one of the research lab of one of the largest sovereign fund Asia in Middle East, and we had this opportunity to learn actually a lot. So CrunchDAO is basically a group of data scientists. We are 6,000 now, 600 PhD, and we don't have a lot of people in Japan, so that's a very, very good opportunity for us to meet you guys. And so, I mean, there were a lot of very deep talks today, and so I was doing my slide at the same time, so I just want to take a bit more height and try to understand why we are all here and why it actually makes sense to do this in such a way. So there is a few slides that I want to go through with you. Let me see if I forget. First, they found the bug in the Microsoft computers. I don't know if you heard about this. It was a memory issue, so we're all going to be able to take the metro tonight. We can go back home. I'll be able to take my flight. It's okay. It was a bad allocation, like always. If you guys program in C in your past or C++, who did some C++ here or some C? Raise your hand. Nobody programmed in C? Okay. Yeah, there's one. Cool. So you know about it. Manual memory allocation. This happened. All right. One question for you guys. What's the common bond between the three images that I'm going to show you? The first image is climate change, let's say. The second image is the stock market. And the third image is an avalanche. Who can tell me what is the common bond between the three images that I just showed? Avalanche, stock market, and climate change. Who has an idea? I think we are all here for that reason, because we're trying to solve this kind of system. And they are called complex systems. So a complex system are a system with many parts that interact with each other. Complex systems show some emergent property, behaviors that are not easily predictable because they will behave together in linear and also non-linear way, which makes complex systems very, very complex and difficult to predict. By definition, it's actually quasi-impossible to predict this kind of system. And this is why I believe we ended up all together today, because we try to solve one of the complex systems that exists on Earth, which is called financial markets. So billions of human networks, billions of companies, and employees, that are working every day. All this information is just ending up in one line of numbers that we need to predict. And that's a very, very complex system. Who in the room can tell me who are these three people? Any idea? So these guys were the first people that, I think, kind of lay out a lot of things. I heard some name of that. Any idea? No, almost. That's Mandelbrot. Mandelbrot worked on Yeah. So Mandelbrot on the right. Who knows someone else? We have Poincaré on the left and Prigogine in the middle. So those people, they started to put some theory on the top of complex system, put some theory on the top of randomness, on the top of chaos. Try to understand this. And I highly encourage you guys to look into this kind of literature. It's very interesting. And so in this complex system, what we will see is that if you look at it from a linear perspective, there is a high chance that you don't see anything. So here, you can see that by using correlation, you will not actually find this kind of pattern. So here, correlation is you have no chance to see these patterns if you are using linear algorithms. And so here as well. So here it's basically a covariance matrix. And if you start to use non-linear technique, you will see patterns emerge. So on the right, you can see the same covariance matrix that is not orthogonal. So there is some hidden relationship that you will find by starting to use non-linear technique. But it's also very dangerous, and we all try and we all fail at this kind of machine learning on complex system because given the amount of noise there is on this data, it's highly probable that we're kind of overfitting on top of this data. And that's basically the main issue that we will face. Now, there is other issue that the Numerai framework kind of solves, and I think it's very interesting the way they do it. Non-stationarity. If you train algorithm on non-stationary data, then every week you have kind of a tendency that will make your algorithm very hard to train because you have a global tendency that makes this number move up or move down. Could be market cycles, could be many different things. So by binning the data inside a cross-sectional framework, you kind of remove this kind of tendency. But we need to trust the people that prepare the data to make sure that there is no non-stationarity inside of it. Second thing that we will face in finance is fat tail. So there is a high chance that the things that's going to kill you one day, it's a fat tail. When you are a PM or if you're managing money, you know that these kind of events tend to happen very rarely, but when they happen, they will be very, very damaging, very far from what you're expecting, and there's a high chance that this kind of event destroy you. I highly recommend that kind of book from Nicholas Taleb that talks a lot about fat tails and black swans. Other kind of pitfall, it's the correlation you will find in the time series in time. And if you look at the quick starters of Numerai, one of the time series cross-validation function is inspired from the work of Marco Pedrado, where you try to make sure that you don't train on some correlation that could happen between the error. That's also one of the pitfalls that you will find by using nonlinear techniques with large data. Another one that I already mentioned is a low signal-to-noise ratio. Here as well, you will find a lot of data, and actually you find it in the data set as well, this kind of distribution that happens. And this is very typical from complex systems, and it's also a big problem. So you don't want to fit that kind of data. P-hacking and backtestable fitting, this one is more of a financial one. But since we apply machine learning to market here, it's also very good at that. Last one, I think, is the pseudo-structure. So the fact that people in the industry are working in small units of research due to the privacy needed in this work, you end up having teams that are duplicating efforts, working on the same subject, trying to solve it several times in several forms, which is a big inefficiency. So it seems nothing like this, but when you look at data that is as clean as what you will find to apply machine learning on, all these subjects have been treated before. And this is why it's a lot of work that happened before we even plug the first machine learning algorithm on the data. So preparing that data is one way to solve all this problem. There's another one which is more game theoretical idea, which is the idea of the collective intelligence and how collective intelligence can solve the problem in a better way than having small team insiders. My favorite example here is Kasparov versus the world. I don't know if you guys heard about this experiment. Who knows it? Did you play it? You did not? So early 2000, Microsoft released one of the first chess games, and to kind of promote it, they decided to organize a party between Kasparov, the best player of all time, chess against 50,000 players in the world. And so you had a small chat, and everybody was voting for the next move. So you could propose a move, and everybody was voting for the next move. The party happened to be a draw, but after the game, Kasparov came back, did a press conference, and said that he actually cheated because he could access the chat. So he could have access to why people were playing that, and what was the idea behind the move. And so Kasparov was so impressed by this game that he wrote the longest book about one chess game that exists in the chess history. Because this game was the most beautiful game he'd never seen. And this guy played hundreds of thousands of games, right, in his whole career. And so that's another very interesting idea that works so well with finance, because you need to find original alpha, right? Original idea that nobody finds. So when you work with 50,000 people around the world, you end up playing a game that nobody played before. And that's fitting very well the kind of problem we try to solve. There's a lot of other aspects, but I really want to focus on the game theoretical one here, which is by having this crowd looking at this problem in a different way, in a non-academic way as well, you come with a completely new solution, and that's very nice. This is a tweet from Jonathan Larkin that I love. I think it was in 2022, maybe 2021. So Jonathan Larkin is managing the Endowment Fund of Columbia, which is a big university in the US. And I think this man kind of sums up what we're doing, right? So we are this kind of guy, you know, and we believe that by being good at a competition, we can find a job. But if we try to push what we do here very far, we may never have to work again. And I think that's a goal we need to keep in mind. Whether it is in Numerai, whether it's in Meetup, whether it's in CrunchDAO, I think there is a future where we could, instead of having a job, kind of play a game. If we're good enough, this game will become our job, right? And this is what I love about this problem. And this kind of future, I really love this vision where your job is kind of a game, right? When you stay at home and you play this game, and you build this model, and this model actually brings you money, and you may never have to work again. And back then, I think CrowdSend, it was the very beginning of CrowdSend, but it's still running, Jo, I think, right? Mid-convention from Peter Cotton at Stanford and Quant Connect from Jared Broad, which is more of a, it's close to Quantopian, but it's more like a quant, like a Bloomberg terminal for quant. All right, so looking at that, I'm going to take some water, and then I'm back. So, looking at this possible future of not having to work, we started to think at the CrunchDAO when we decided to come with this framework where we could have a foundation in the middle that will be the first intermediary between two kinds of people, the people that cannot share their data and the scientists that don't want to share their IP. So those people will never be able to work together because this company cannot recruit this guy and this guy actually don't want to work at these companies. They can work at Google, they can work at so many interesting jobs now that working in a hedge fund is often kind of boring. So by having this company providing data to a platform, having the guy looking at this data on the platform, you can kind of create a new market where those people can work together and can talk together. And the first customer we had on the platform, you may have heard about them. It was Crunch Capital. Crunch Capital is composed of data crunch. Some of you guys may have participated back then. So there is an equity fund, there is a VC fund, there is a real estate fund, and we will launch a crypto fund soon. Those entities are engaged in profit sharing with the foundation, and the profit are directly redistributed to the participants. What is nice about this setup is that the community doesn't depend on one financial feed, but depends on many other entities. And it actually goes further, because finance is just one use case, right? There is a many very vertical industry that could be kind of solved that way. Like there is so many rankings in the world. I think we are all good at rankings. We could learn to rank algorithms, whether it's at Numerai or other tournaments. There is so many use cases that we could solve and that we could get paid for. So we decided to kind of go that road where we could solve so many problems for institutions or for whoever want to work with us. That's an example of what could be done for a VC fund. For example, we've been working with this fund called X Alpha. It's a venture capital fund, so they're investing in startups. And so what we did for them is basically putting a lot of data about the founders, anonymize all of that, quantize all the data using the differential privacy to make sure that the data doesn't leak, and build an investment strategy based on that. And since this industry is not really quantitative, you can see that you can easily bring some value there. So going from there, I think it would be nice to show you a bit of the platform and how we actually work. So let me go in there. Internet is a bit slow, it should work. Yeah, it should work. Hopefully, so what is crunching a bit, and maybe go to another version. So let's say we are in this kind of setup, we can work with any company, we can solve problems for any kind of company that needs rankings. The first that came to mind are obviously financial. So we work with the Hérelle lab. We just create a data set that is a ranking problem, cross-sectional issue, obfuscated data set, shuffled in one in each area, so we know that very well. That's a Numerai setup. And the client will receive the prediction of many different models that can assemble and build its own data model. So today, the biggest customer we have are actually Hérelle, and you probably know Marco Lopez de Prado from the book that you can get from
from Amazon. It's a very interesting book. I highly recommend this book for anyone that wants to apply machine learning to finance. So I think that today this kind of companies, they see more and more us as an opportunity to outsource a part of their research, right? So let's say you start talking to any kind of, it could be healthcare, it could be logistic, it could be any kind of algorithm that we could start solving with our solution. And I think we are kind of credible. If you look at the track record of the competition in Kaggle, for example, you'll figure out that they beat industry benchmark in a very, very confident way. There is this General Electric competition that was running in which you have to predict, for example, how late the plane is going to be. The previous benchmark was at 4.6, so 4 minutes, and they bring it down to 3.2. That's a big industry change. There's so many examples like that. I don't know, should I change network maybe?
It's like connecting together network. So let's try to do Wi-Fi.
Yeah.
So you could try one 5G, same thing as now one. So,
Is it this one?
yeah, same password. Okay, I can type it.
Yeah. So definitely okay.
So
Yeah.
okay, let's try again.
Yeah, so it's better. Let's go. Let me change. Okay. Okay, that's it. So let's say we can start plugging models into the infrastructure of many different customers. And if we do that, we kind of find a solution to scale the incentive mechanism, because when you're trying to solve a complex system, there is no big winners, right? We don't see a model as being like 20, 30% higher than the other model, right? I'm pretty sure that we see the same thing. It's kind of a swarm of models that is evolving together, and we are all solving together that. And since there is no big winner, it's hard to have also big incentive and big win out. So one solution is either scaling that to different products, scaling that to different fonts, scaling that to different applications. And that's really the vision we try to have here. So one model can be connected to different products. So let's say we take something very similar to what you guys have at Numerai. That's alternative risk premium product, so long short, equity, very noisy, quantized target, quantized asset, etc. So instead of submitting just a prediction, what we try to push more and more is to have people use the capacity of submitting a model. So you guys can, enjoy the retraining of the model, enjoy the automatic submission, this kind of thing. Because put yourself in the feet of an asset manager that have to rely on this kind of system. I don't know, knowing that you will not submit because you didn't wake up or the model is not available or not. That's an issue. There is another big issue, which is the non-determinism of the submission. What we realize is that there is maybe 60% of the submission that are non-deterministic. So meaning that every time you retrain your model, it's a new model, right? So if you retrain it every week you submit a completely different object, and building a meta model on top of that is very hard. So by having the capacity of testing this has been a big improvement in our meta modeling capacity, because we realized that 60% of people were non-deterministic, so not usable to do some predicting job. You can as well you can send some test data to the model, you can retrain at different frequency, you can run some Monte Carlo simulations with the models. All this is doable if you have the capacity of executing the code. And that's really where the magic happens. So let's say I want to set up the model here. You have like many different kind of tournaments, you have a token. You have to set up an environment because you need to know who you are to get you down the data, basically. So right now at the state we are, you can submit a notebook, you can submit with CLI, you can submit directly your model file, you can submit just a prediction if you want. But if you submit code, you have to comply with some whitelisted library. Obviously, we are running your code on our instance, so it's very, very dangerous. In here, we are setting, getting the data. And I think I'm going to pass on that because it's kind of redundant in a different project. It's just getting the data, logging the data. You have features and targets. You have time cross-section. And then you just submit. You have some test function if you want to test it, you just submit your notebook directly. So once you submit it, basically your job is done. So the only thing you will have to do is to make sure that your run is coding every week. It's running every week. So when you submit, we take your code, we pass it, and we will dispatch your code inside 3 different files. Main, requirement, and execute your submission. The requirement is making sure that when we go to run the submission, all the libraries and all the text you need is behind. So we pass your code, we put it in these files, and then every week or every time a customer is going to trigger your model, we're going to fire Docker, install all the requested library, run your code, and send the prediction to the customer. But the model never leaves the foundation, right? The customer is just getting the prediction. So that's a pass code. And that's basically what you see when your model is running every week. So every week you have the log of the model. Apparently my code is not very, okay, that's just warning, but basically your code will run every week and you will see that you get your metrics. So I think that's something that made us make some big progress. Leaderboards, same thing as what you guys are using Numerai. You have a reward distributed in USDC, so in $1. And every week when your model is run, the reward is automatically dispatched. You have different type of target, we have reward for different kind of target, but that's kind of there. I think the main points that I want to make here is you have to make sure that you have the control on the model, kind of to make sure that you can operate the product. And that's something that I feel in the air when I see Flock, decentralized learning, what we've seen this morning about the compute online, etc. And I think that's something we all have to face. All right, that's it, guys. Do you have any question?
I do have a question for you. So, if I understand correctly, so all the compute cost is paid by one?
So it's paid by the customer of the foundation. So today you have, I think it's one of the main errors in what we're doing is trying to have compute power. And so if someone wants to use your IP and get prediction from your model, he has to pay for the compute, right? Because it's kind of a main issue for us. So in this framework, we do believe that there are going to be hundreds of companies that are going to need model in the future, right? And these companies will have a lot of hard time in recruiting data scientists and recruiting the best one. And so there is an opportunity for us to kind of provide this lack of modeling. And so in this future, you have, like in the Go game, you have an infinity of games that can be played, right? So there is an infinity of application that the model could be plugged to, and that's basically what this framework is trying to provide. So basically, any customer can come, upload an obfuscated data set on the platform, this launch the crunch, then the guys can get the data, can build your model, submit the model, all the compute will be operated, all the data, everything is operated for you. You have nothing to do. Basically, as simple as a git push. And this diagram shows you how kind of the overall machine is running. So people are pushing models. We operate about 3,000 GPUs, 24,000 virtual CPUs, and the customer are providing the obfuscated data. So all you have to do is submit once. Once you submit it once, we recall and recall the code every week. So yeah, compute is paid. But there is also a trade-off with that. If it's paid, then it means that the customer sets the limit. Right, so in that case, you can still use your own hardware, but you will only be able to submit the model. If you only submit the model, then you cannot enjoy your retraining. But the retraining is not very necessary. It can be necessary if you have a very shallow model, but I don't think it's necessary for a deep model. You can retrain maybe every month or every 6 months, if you're kind of deep in the data. I mean, that's what we see at least.
Thank you. So I have a second question for you.
Yeah.
So how do we earn rewards? Do we need to buy the token first and stake on it like Numerai? You have to stake on it. And this one, you only submit your model. So yeah, right?
Yeah, exactly. We believe that you already made a lot of investment with your time, and we also believe that you can find a solution to this skin in the game with your reputation. So the more someone is participating, and the more is earning, the more reputation it has. Also, we should not mix the civil attack problem with the skin in the game. So there is two problems we are facing in this kind of community. One is Iran, North Korea, firing a lot of GPU and sending you a lot of prediction, random, 1 minus P, and all these kind of things. That happened at Numerai, it happened on our infrastructure as well. So those guys, we don't want to have that. So you need to detect the people that operate many different accounts. That's one issue. It's called the civil attacks. The other one are people that are spending time on the platform building models, good models. And those guys are doing great jobs. And we need to embrace the diversity there. It's very good to have a shallow model, deep model, because we're facing a complex system again. So the more solution we have, the better it is. You just need to make sure they are not trying to game the game right. That's what you try to avoid. But there is techniques to do that. I'm not going to reveal it, because the right is similar to know how we figure out not having them on the network. But it's game theoretical again.
Thanks. Okay, thank you, John. Thank you for your time. Thank you.